Hello, everybody. Welcome to the lecture video on an introduction to data literacy. So today we're going to talk a little bit about the basics of data literacy and how to think about data, and then kind of the basics about how to read data. So it basically goes through the DIKW pyramid, and then kind of a five-step process to make data-driven decisions. And throughout the lecture, I'm going to use Spotify as an example. And then Spotify, kind of the same example, will be used in your first discussion post. So just to motivate the whole presentation, we really live in this data era. We are collecting data, um, collecting more data than we ever have as a species ever in our whole human history. Data is all around us. It's similar to how computers and the internet transformed, kind of lives in the past. Data is really transforming how businesses work now. It's all, it's been said that data is the new oil. Companies make billions of dollars on our data, collecting it, analyzing it, selling it, that type of thing. So, really, the fundamental foundational belief here in the business world is that data is really essential and valuable for businesses to make sense of their customer. And we can't really just say, I feel that anymore. That's my gut instinct anymore. We really need data to kind of guide our decisions. So there's this new concept called data literacy that a lot of companies are advocating that colleges kind of teach students. And I also think it's very important for students to understand a lot more about data than they ever did before because of this, because we have too much data. So data literacy is really essential for understanding and interacting in this kind of data-rich world. So hopefully by the end of this lesson and then next week as well, you'll know a little bit more about how to approach data, how to think about data, what data actually means. Yeah, so here's a stat. So throughout 2024, approximately 402 million terabytes of data are generated daily, which is just insane. You know, 20 years ago, this was not a thing. Um, 50 years ago, grandparents and parents could not even fathom how much data would ever be collected. Even if you think about, data in airplanes, and there's always a stat that says like there's more processing power in our phones than there ever was in the Apollo mission, the Apollo spaceship that landed on the moon. So you can go to the moon with kind of more primitive technology than you have basically in your pocket, and everything you do on the internet and in your phone is collected. And once you push enter or type something on Google or whatever, all that is stored somewhere in the cloud. And we'll talk about cloud again in a few weeks. But all the data that you kind of everything you do on the internet is data, and it's all stored somewhere. So there's a ton. This is just daily. We need these data warehouses. We need um, the tools to really analyze the data. So every day, new data is created, new data is captured, new data is copied, new data is consumed. So if you take a step back and think about your phone, for example, and about your life, um, think about everything you do on your phone and everything you do on the internet and how your life would be different without that access to data. And think about every single time you type in a movie to Netflix or search something online, how that data is actually stored and how it's actually used to give you information. Um, so I looked quickly on ChatGPT. So this is equivalent to 88 billion DVDs a day, and then almost 600 billion CDs a day. So there is a TED Talk on data literacy here if you're interested. It's not required. Also posted in the discussion post if you want to watch it, but it is interesting. So what is data literacy? I talked a little bit about it before. So here's an official definition: the ability to read, work with, analyze, and communicate insights from data. So to understand, what data is, you need to be able to read it. You need to be able to do something with it, make sense of it, and then actually tell people what you found. You'd be surprised that the communicate part is often the hardest part. Analyzing it, the skills to do that can always be taught. How to read data can also be taught. Communicating, is practice, practice, practice. And some people are better communicators than others. But communication is often one of the hardest parts for students to learn, and not just students, but people in the actual workforce, because you have to get your ideas across. And if you really can't communicate what you've read, or found in your analysis, then it's really hard to really get anything done. So components of data literacy again is reading, working with, communicating, and kind of arguing with data. Um, this one doesn't really say arguing, but there's this kind of notion. I think it was in the TED Talk that talks about that if you're going to actually make a point, not necessarily like being combative, but you need to actually use data to kind of help you to assist with that point. Um, and again, this will be you in the future. So the ability to read, work with, analyze, and communicate will kind of be ingrained in what you do as you enter your careers. So again, I can't emphasize this enough. It's very important to understand that data will be kind of a central component of your life going forward um, in the business world. So data literacy as a life skill. Data literacy enables us to extract insights from complex information. Um, and a lot of it is really more about creativity and critical thinking about what you do with data and kind of what the data actually means. So about critical thinking and context. So the technical skills of, analyzing data can always be taught. So like coding or data visualization or that type of thing. But one of the most critical aspects of data and actually reading data and using it is kind of critically thinking about what data is and how it can be used like creatively to give you kind of a competitive advantage over your competition. And actually thinking more about what data you actually need to capture inside the system so that you can use it to get a competitive advantage because you can't really capture data if you don't have the fields necessary to capture it. So you need to, or you call it collect it. You need to collect data before you can analyze it. So the creativity and critical thinking and understanding whatever context that you're using the data for is very important. So when you're actually designing systems to collect data, because you need to collect it first, you really need to think about what data you want to actually collect. And the people that do that the best are the ones that are going to give that competitive edge. And that really takes creativity. So a lot of people are kind of arguing that a lot of these systems like machine learning and AI and analytics and all that stuff, um, the technical skills are there. They're pretty straightforward to learn often. They can be taught, but the creativity really is the hardest one to teach. Like actually, collecting data on actually, for example, if you're using Spotify, knowing the intricacies of music and kind of collecting data on how to recommend songs to users is very critical. And knowing music so well and being creative about how you actually collect that data and recommend that data can really set you apart from another company's algorithm because that human insight can't be gained by a machine. Um, so again, I said this before, but data literacy is becoming more important, kind of arguing and making your point over data. A lot of times I'll say this, like, I feel like this happened or I feel like that happened, but especially in an organizational setting, you really need that data to back you up. So if you're making a point, if you're trying to sell a project, if you're making a budget or anything, whatever you're doing, you really need that data as kind of a skill in life and in business. So this concept is called, it's more of a lens to understand what data really is and its relationship to things like information and knowledge and wisdom. So a lot of times we say data and information interchangeably, but really they actually mean two different things. So the data is really the bottom here of this pyramid, and then it goes up to information, up to knowledge, up to wisdom. So this pyramid that people talk about is kind of a lens or a framework to really understand data. So you start with the actual data. So what data really is the raw facts and raw figures. So kind of if you look at a spreadsheet with just numbers in it, you really don't understand what that means. Um, so this is kind of at the collection phase of doing a data project. You really need to understand the actual data you need to collect so that you can make some sense of whatever you're making sense of. You need to know at that foundational level how we're going to collect this, what numbers we need, what categories we need, what words we need basically, and then all this stuff is basically just kind of scattered without much organization at all. So it doesn't really have any meaning here. It's just kind of numbers and words. So if you were to download like a Spotify data set and someone made a playlist called Cool Playlists, that doesn't really mean anything. It's kind of like up to you as the analyst to understand what cool means and what, playlist means and what cool playlist means together based on the artists and types of music that are in an individual person's playlist. So once you have that data, once you have that kind of raw, these figures, then you get to information. So this is actually really where you get the context aspect of data collection. So data placed into context is actually information. So once put that song title into, next to an artist or something, it actually gives something a meaning, right? Context gives everything a meaning. You can't. Everything is kind of meaningless without context. So, for example, the number 15 means you played a song 15 times. So instead of here, you would just have like a number 15 followed by a comma, a number 20 followed by another comma, a number 17. Like this is meaningless. But then when you actually kind of understand what this means, you can say, oh, these are kind of plays or hours listened or whatever in a Spotify sense. So describing a song as cool, does that mean you actually like the song? Do you mean this is kind of cool in whatever setting that you're in? Does this mean cool like you like to listen to this stuff when it gets cold outside or cooler weather, sweater weather type songs, that type of thing. So it's kind of up to you to contextualize the data, right? Because you as the analyst or you as the person working with the project is kind of going to understand the context more and the data around it. Once you kind of get that context down, then you start to extract patterns and make connections amongst the data. So, if you actually were to analyze someone's playlists and you found something called workout playlists, and then you kind of found with the data that, you know, there's also data on tempo, right? So you as the data person would design a project to say, we need to collect something like tempo or beats per minute or something like that. Um, and if you were to analyze a workout playlist, you'd say, hey, this person really likes high energy songs, which is defined by beats per minute, right? So then you would understand that, over time, this single person, and if you were to kind of apply that generally to other people who titled their playlists workout playlists or exercise playlists or running playlists or something like that, you might be able to actually find a pattern and make a connection between like up-tempo songs and working out. And that would give you knowledge, right? Then you would have knowledge over your user base, for example, in Spotify. So this kind of patterns that hold over time. So over time, maybe you would develop a hypothesis that says when people work out, they like to work out to up-tempo songs. So one example, back to my kind of Spotify Wrapped. So does cool mean, in my day, I always thought Green Day was really cool. Or maybe now if you see people that type cool in to their playlist, it actually means, they're old or something. Maybe people don't say the word cool anymore. there's kind of a language gap often between generations. So like baby boomers and Gen X to millennials to Gen Z, of course, people typically speak the same language, but there's a lot of nuances to language, and maybe, the word cool isn't cool anymore, if you see what I'm saying. So again, overall knowledge, kind of this enables you to make these generalizations. For example, like workout playlists are usually upbeat songs. And if you kind of find that generalization, then you can make a prediction from that knowledge. So then you would make like a hypothesis and predict that most workout playlists are upbeat songs. And then you could potentially suggest playlists to people and make sure to include upbeat songs in that playlist. And once you get knowledge, then you get to the W part of the DIKW pyramid, and this is wisdom. So these are really actionable insights based on your knowledge. So again, going back to the workout playlist, you kind of act on your hypothesis. So you really kind of start to make hypotheses here. I'm just going to write hypo here, or make predictions here with your knowledge. And then, you would test this stuff, and then you'd actually take action, and that would give you wisdom. So you'd say, these are typically based on patterns for future actions and predictions. So you have all these patterns that you've gained, and then you take action by designing the actual uh, programmed Spotify workout playlist, for example. And that, you kind of test that a little bit and then release it to everyone, who typed in workout. You make sure all the playlists have upbeat songs. Um, so, for example, here another one based on the Green Day, uh, my Spotify Wrapped, if you watch the intro video. So, recommending 90s alternative playlists because you listen to a 90s alternative podcast. So, one of my favorite podcasts I've been listening to recently is um, it's like the top 60 songs of the 90s. And you basically listen, I listen to that all the time. So, if you kind of build, if you place the people who listen to that, give that meaning, you build knowledge from that and say the people that listen to this typically listen to these types of bands, and then you take action on that and actually start recommending more 90s alternative playlists because you made that prediction and hypothesis and their knowledge, and that would give you wisdom over, that specific type of thing of people that listen to 90s alternative podcasts to make that prediction. And all this is happening, for example, in Spotify, uh, it's happening, hundreds of thousands of times per, hour on millions of individuals' playlists. So a lot of this stuff that's happening inside of the platform is, behind the scenes, a data analyst is working on a specific project related to, placing data into context, kind of gathering knowledge and finding patterns from that using analysis tools, and then kind of testing that and taking action through wisdom based on specific predictions, basically. So that was the DIKW pyramid. Now there's this these steps to actually kind of making this data-driven decision making. Um, there's kind of a method here that people really need to follow. So when you think of data, a lot of times you'll hear people say, "Oh, we need to make decisions based on data." So this term you'll hear a lot, data-driven decision making. So actually making decisions based on something versus nothing. This is also really popular in medicine. So having kind of data-driven medical decisions. And there are certain steps. So this is kind of like the scientific method. Often you'll hear uh, data described in terms of like data analysis or data science. So there's different basically steps here to kind of drive your decision making and make sure that you're following some kind of method rather than just saying, I think this is the case. Um, so there is a definition here of the 5 steps. So using data to make informed decisions and take action. So again, this is kind of like data science, and if you remember the scientific method, This is basically like steps to make sure that you're analyzing your data properly and that you can think about your data in kind of a methodological way or methodical way. So the steps are defining the problem, collecting the data, analyzing the data, communicating the results, and taking action. So it kind of relates to the DIKW pyramid a little bit, just a different way to look at it. Okay, so I'm going to give you an example of the 5 steps through Spotify's Discover Weekly um, recommendation tool. So basically, every Monday or so, Spotify gives users a recommendation of different types of songs that they think the user will like. I don't know how many of you use this, but it's kind of a neat little tool. I use it occasionally just to find new songs. So I'll put little quotations here. Um, yeah, so we have some actual context about the steps. Remember, it's hard to really talk about something if you don't really have the context. So I just want to contextualize this. So in the 5 steps of data-driven decision making, the first step is define the problem. So you actually need to identify something very specific. So you need to actually have a goal, right? You can't just kind of look at data and not really have a goal. You need to have kind of an overarching structure to what you're actually planning on doing. So, for example, with this Discover Weekly, Spotify wants to increase user interaction with its platform, the Discover Weekly feature, which users are not really exploring. So this is kind of a hypothetical situation. So they're saying we have this feature, why aren't users exploring it? Let's kind of have the goal to increase user interaction with Discover Weekly. So the second thing you want to do in your data-driven decision making in your little data project is you need to actually collect the data. So you need to decide on the actual relevant data needed to collect related to whatever goal that you actually defined. So if you want to increase user interaction with Discover Weekly, you need to collect data that's actually relevant to that. So these are some examples. So the number of users accessing Discover Weekly. So you need to actually know like how many people are using it or not. So just kind of pretend that you're working on this problem for Spotify. You can collect data on the skip and save rates for songs. So Spotify actually tracks you if you add a song to a playlist or you like a song or you rate a song, that type of thing. So are people actually interacting with the Discover Weekly feature when they use it? How about also the average time they're actually spending on Spotify after using Discover Weekly? So the whole goal of Discover Weekly is for you to discover new music. And are you really interacting with Spotify more or less after doing that? Would be interesting to know. And then some demographics of the actual users engaging with this. So what type of user really uh, engages with the Discover Weekly? Is it older people, younger people, uh, men, women, non-binary, that type of thing? Where do they live in the country? Are they more in America? Are they global? Anything really relevant here could help you decide on uh, kind of next steps. The actionable steps, basically. Then step 3 is after you've really collected that data related to your goal, you need to analyze that. And a lot of you probably have not analyzed much data. I guess you've taken MIS 220. So you've used Excel. Excel, isn't really thought of as a data analytics tool, but it's actually like one of the, first and most widely used ones. Spreadsheets, can do a lot and they are very powerful. You can also get a very good look at your data using Excel. So don't underestimate the power of Excel. There's also a lot of other different types of tools here. For example, I teach a class on data visualization in Tableau. It's kind of like a specific visualization tool that you can actually do data storytelling with. Um, Microsoft has a similar one called Power BI. That's kind of more of a visualization tool besides Excel. Excel can do visualization, of course, but Power BI can do it in a little bit different way. And then there's R. so kind of a programming language. Python, also widely used programming language for machine learning, that type of thing. SAS, kind of a statistical analysis tool. And there's a lot of other different types of tools like RapidMiner, Splunk, these types of things. And these are often found, for example, when we talk about cloud computing, there's kind of a suite of different tools that you'll need to make sense of data. And these are all a part of, kind of storytelling with your data. So actually using these tools to analyze the data to basically crunch all the numbers and analyze the, you know, uh, qualitative data, the words. Um, it can be kind of overwhelming because there are so many tools, but there are these kind of core tools that people use. So, for example, if you were to analyze the data that we just collected, you could potentially find only 40% of Spotify users open the playlist. So that would be interesting to note that 60% of people don't even open the weekly playlist. So you want to really narrow down your base here. So you could have like a focus on the 40 users that do open, and then you could also have another project on the 60% of users that don't, right? So if you want to focus on the do, and then this is do not, don't, you could have two separate projects going here if you're an analyst. So, why don't they? You could collect more data on these people, but you could also kind of zoom in on the 40% here. You could also potentially find that songs with upbeat tempos, like we talked about, have higher save rates compared to slower songs. So potentially people like faster music. Maybe they don't really like the slow and depressing songs. Maybe not a lot of Radiohead here. I like Radiohead, but they do have a lot of slow songs. And then another potential finding, users who engage with Discover Weekly, they actually explore more playlists on the weekend. So if you're actually dropping the playlist on Monday, um, and users are using it on, Saturday and Sunday, maybe your strategy could change a little bit. Maybe it'd be like a kind of a Friday thing. I don't know. But these are kind of potential findings. And then you have, projects based on these findings. So how to increase the rate of these 40%, one project, and then you could find out, why don't these 60% use the Discover Weekly playlist. So example of 5 steps continued. Step 4 is you need to actually communicate these results. So if you remember previously, I talked about how communicating the results is actually like one of the most important things you need to do because you can always have the skills to analyze the results. There's a lot of people that know how to do that, but there's not a lot of people that are great communicators and can actually, it's called data storytelling. So actually tell like a good story about why your results matter. There's statistics. 49% of individuals feel their organizations lack storytelling skills, regardless of if you're data literate or not. There's also some stats that say stories are 22 times more memorable than facts alone. So, kind of having that narrative in your findings is key. Not just saying, 40% of people don't use, or 60% of people don't use Discover Weekly. You'd have kind of a story about who these people are, how they're interacting with Discover Weekly, that type of thing to really communicate your results and tell people like why your results matter and how you can kind of fix the results. So in Spotify's case, you could present the findings through different graphics. So line charts, heat maps, bar graphs, but you really need to tell the narrative and have a story behind those things um, rather than just showing the visuals. It's one thing to really show the different graphs, but it's another thing to have that narrative of, why people tend to like upbeat songs, for example, and then using that narrative to really drive home and justify what actions you're going to take. So if you really capture and captivate your audience, you can really start to implement these changes. So you need to like base these changes on your analysis, and your ability to communicate are two very key important steps in the uh, data-driven decision-making model, basically. So, for example, your actions could potentially be send personalized notification to users on weekends because they're more likely to engage on the weekend, and then adjust your algorithm to prioritize songs with higher engagement rates. So, like have more upbeat songs, for example. Um, so you could potentially like take action and try to increase that engagement from 40% to, you'd have a goal, you'd say 40 to 50 or 40 to 45 or something like that. So again, the actions are based on the analysis and based on the communication. And if you don't have both of those things and you don't have the creativity to actually come up with this insight and to collect the data in the first place, then those things are key. You can learn the technical skills, but you can't really learn creativity, and it's hard to learn communication. So my suggestion is just, practice this stuff, talk about data, talk about what you're seeing, try to make sense of things through storytelling, through narrative, um, and then people will kind of be more willing to listen to you. And then, those are the 5 steps. But there's also common data problems. So there are problems you might run into on some data driven projects. So there's stuff to note, right? There's something called dirty data. So incorrect, incomplete, or inconsistent data. So for example, in Spotify, there could be mislabeled song data, missing genre data. For example, The Weeknd has a song called Blinding Lights, but I believe it's capitalized. Um, I also saw that there's a Billie Eilish song called Birds of a Feather, and that's also capitalized. So when I saw that in Spotify, I was like, this could potentially be dirty data because the tendency is to kind of make it, you know, use an uppercase at the beginning versus like all uppercase or even misspelled words. So say you're an up and coming band and you don't include all the genres, then you might actually not get added to playlists because your songs are mislabeled and you don't really have a genre or something like that. There could be missing data. So, for example, in Spotify, songs uploaded by independent artists may not have a tempo, may not have this data behind the scenes, may not have genre, the release data, etc. And if you don't have that if you don't have that data present, you might not actually be included in the conversation. There's also something called data bias, which we'll talk about in either next week or a couple weeks. But there could potentially be societal biases in the actual data themselves. So, for example, Spotify's algorithms might suggest playlists from top charting artists, like really highly played users, and more mainstream genres because they kind of dominate play counts and user interaction. So, kind of more obscure stuff may not actually get to you because people don't tend to listen to it. And Spotify might favor kind of more played songs when generating playlists. So recommendations might favor music in regions where Spotify has more users. So it doesn't necessarily mean that people are listening to this stuff more. It just means that some areas might have more users than other areas. And that could bias the actual data because the counts of the songs would be higher just because of the number of users rather than the fact that people are listening to it. And then there's something called data cleaning. So you'll do a lot of projects if you work with data in college, and a lot of the data sets will be nice and clean so that you can learn how to analyze it. But in real life, a lot of the data comes from different sources and different areas through different people, and you need to kind of connect a lot of this data and a lot of missing data and that types of things. So there is a really whole field in data cleaning so that analysts can do their jobs and that AI can kind of make sense of the data. So there's a lot of cleaning going on behind the scenes. There's a lot of testing going on behind the scenes. So something to remember. And then overall, kind of the broader career impacts of data literacy. So if you remember, we are chatting about data literacy in general. Um, So again, I'd like to emphasize data literacy is critical across many industries. Um, this is supposed to say not just MIS. Sorry. So healthcare, there's a lot of data in predicting patient trends, managing hospital bed access, rooms, that type of thing. A lot of data in marketing, understanding actual consumer behavior. A lot of data in finance through risk analysis. And then, of course, MIS majors are usually the ones designing and setting everything up, and a lot of times analyzing the data. So, for example, the MIS major here has a lot of classes on data analysis, so you really learn the ins and outs of data. And that's pretty much it for the lecture. So just remember your discussion post for this week. I kind of want you to, it's basically just completing an assignment. Um, the scenario is basically what we just talked about. So I want you to kind of go through the whole kind of method of the DIKW and the 5 steps of decision making. So Spotify wants to increase user engagement with Discover Weekly. While it's popular amongst some users, many others don't interact with it regularly. So your task is to imagine you are a data analyst and your tasks with planning the project through the lens of the pyramid and the 5 steps. So there's a couple of bullet points for each step. And you kind of just have to imagine you're the analyst and tell me, get creative here and kind of tell me what you would do, what potential findings you would have, that type of thing. So just remember it's due on Wednesday and email me if you have any questions. So good luck.